Hello everyone, and welcome to the Climate Change Debate, hosted by the Stevenson Truth Seekers Club. I'm Luke Alexander, and this is Michelle Kellerick, and we'll be your MCs for the evening.
We'd like to take a moment first and thank you all for taking time out of your evening to come here. We hope you consider asking a question during the open mic portion of the evening.
Established 20 years ago, the Truth Seekers Club is an informal philosophy discussion group. About 50 topics are nominated at the beginning of each semester, and then students vote to identify the top topics for discussion throughout the course of the year. Topics that students have selected for this semester include the following.
Should we have the right to bear arms? The movie 2016. Is morality objective or subjective? Is it desirable for America to become the world's moral standard? Is education important? Luke, do you think education is important?
Well, Michelle, I've always believed that it is, but if most Americans don't, then it's probably not a good idea for America to be the world's moral standard.
Good point, Luke. The focus of tonight's debate is the cause of climate change. Are humans to blame for the droughts, the floods, the scorching hot summers, the deep freeze winters, and Hurricane Sandy? Or are the non-human factors, such as natural fluctuations of the intensity of the sun's radiation, the true cause of climate change? Mr. Wilms will defend the claim that climate change is in fact caused by humans. Mr. Haan will defend the claim that climate change is not caused by humans.
So, why are we having this debate? We believe that this is a high-stakes question. Al Gore wrote on October 30th that Hurricane Sandy was, quote, strengthened by the climate crisis. He went on to assert that dirty energy makes dirty weather. Leaders like Al Gore are urging us to help end the climate crisis by making costly sacrifices to invest in, among other things, alternate forms of energy. But if we're not actually causing the climate crisis, we may be wasting precious resources that we could use somewhere else. Another reason we're holding this debate is to give students a safe place to sort out issues with minimal pressure to agree with one side or the other. As students, we've noticed that some people in positions of authority, some of whom are scientists, insist that this issue is settled. Yet other figures of authority, some of whom are also scientists, insist that it is not. We students sometimes have trouble finding an emotionally safe place to consider both sides of the issue. And to top it off, critical thinking on this issue is not consistently encouraged by the media.
Well, Luke, I have an example of the trouble you're describing from my friend Nikita Luthrop, who says, I remember distinctly in the 6th grade having to watch Al Gore's documentary, The Inconvenient Truth, as part of science class. As young students, we didn't even question the theories that climate change is man-made. All we took away from it was an awareness that we have to treat the planet better and be more efficient with using our resources. Looking back throughout my education, I realized I was never exposed to the opposite side, that climate change is a natural part of the Earth's cycle. Although my beliefs today have been unchallenged, I realize that I wish I had been exposed to the contrary view. That's why this debate is so important, to offer both opinions on a level playing field.
So, in an effort to serve you, the students and community of the Stevenson High School, the Truth Seekers Club has planned this evening.
If you'd like to discuss this issue further, come to the next meeting of Truth Seekers, which is next Wednesday after school until 4:45 in room 2900. Additionally, if you'd like to read any further about this issue, both Mr. Haan and Mr. Wilms have provided information that will be on the Truth Seekers website.
Posters all around the auditorium are Truth Seekers posters that contain the QR code for the Truth Seekers website. If you have the capability to use your phone to scan the QR code, then, after the debate, you may scan the QR code for the Truth Seekers website on your way out. Another way to obtain the Truth Seekers link is to send an email to the Truth Seekers faculty advisor, Mr. Royce. His email address is nroyce@d125.org. A video of tonight's debate may be posted on YouTube. Therefore, we ask that you please refrain from recording the contents of tonight's debate. And now, please silence your phones for the duration of the debate. While you do so, another item on the Truth Seekers website is a link to a video of our previous debate in May of 2011. Mr. Royce and Mr. Erdman debated the question of whether evolution or intelligent design is a better scientific explanation for the origin of life.
Luke, did you attend that debate?
You know, I didn't, Michelle, but since it was posted on YouTube, I was able to watch that from the comfort of my own home on youtube.com.
And now the format for tonight's debate. First, each speaker, starting with Mr. Wilms, will have a 20-minute opening statement. Then, for 15 minutes, Mr. Wilms and Mr. Haan will interact without moderation. We will have the fascinating opportunity to observe the extent to which these men are able to govern themselves. Ahem, Mr. Haan? To the best of our knowledge, this unmoderated portion of the evening is unprecedented in the modern history of debate. Anything could happen. Then, the formal portion of the debate will end with each debater delivering a 5-minute closing statement, with Mr. Haan having the final word.
Each segment is timed by students. In each portion, when 1 minute remains, a designated student sitting in the front row will raise a yellow card. When we have reached the end of the allotted time for the section, the designated student, Mr. Stephen Rice, will raise a red card. Following the closing arguments, there will be 45 minutes of moderated open mic Q&A. You will be given an opportunity to approach one of the 2 audience microphones at either end of the aisle and ask a question to either Mr. Wilms, Mr. Haan, or both.
And now, Stevenson Senior Sid Dash will come to introduce Mr. Haan.
Thank you. Mr. Haan is a 23-year veteran Stevenson teacher of economics and advanced economics. He has a bachelor's and master's in economics. Since the global warming controversy started in 1989, Mr. Haan has been a close follower, and he really takes an interest in the controversy. He's really devoted to ensuring that his students become critical thinkers when trying to solve everyday problems. And now on a more personal note, Mr. Haan has really had a big impact on my life, and I will definitely remember him for the rest of my life. Last year, he was my AP microeconomics teacher, and I think the reason that I will remember him is because he really gave me a perspective that I'd never had before. For the last 18 years of my life, I've been told global warming has been caused by humans. It's really a horrendous thing. And I think what Mr. Haan did was to give you an idea of the other side of the argument. And I think that's essential when you make a decision that could impact the rest of the world and that could impact the lifestyle that you have for the rest of your life. And that's why I applaud Mr. Haan as someone who really teaches his students how to think and not just take one point of view, because that's not how you should make an informed decision. And I must say, Mr. Haan is the nicest guy I know. And every day in his class was a treat. Thank you.
And now I'm pleased to introduce Hannah Schlachter, who will introduce Mr. Wilms. Hannah?
Mr. Wilms has been a teacher for 34 years and has taught AP Environmental Science and Accelerated Biology here at Stevenson. The past few years, he was a sustainability coordinator for Stevenson High School and helped our school become the first LEED EV Gold certified public high school in the country. Mr. Wilms has recently been awarded the Community Educator of the Year for the state of Illinois by the High School Activities Directors in 2011. In 2010, he was the Northern Environmental Science Teacher of the Year in the Chicagoland area. In addition, Mr. Wilms has worked with Northwestern University to develop teacher workshops in climate change and renewable energy options. Recently, he presented at a National Electric Vehicle Conference about the future of clean energy and electric vehicles. Having worked with Mr. Wilms for the past 3 years through Stevenson's very own Green Team, the environmental club here at Stevenson, I can personally say that Mr. Wilms loves to share his passion for science, education, curiosity, and respect for the biosphere we call Earth. Without further ado, Mr. Wilms.
All right, so like Hannah said, we'd like to present Mr. Wilms, who will be delivering his 20-minute opening statement. Timers, are you ready? All right. Mr. Wilms, you may begin your 20-minute opening statement now.
All right. Is this on? I have a green card, so I'm going to go forward. First of all, I want to say it's really nice of all of you to show up this evening. I know how busy you are. Stevenson is a great school. I love teaching here for so long, and although I've retired, I carry all the student enthusiasm and curiosity with me all the time. You guys give me a lot of hope for the future, and I think tonight's going to be very good. I hope that I learned some things from Mr. Haan. Hopefully Mr. Haan will learn a few things from me, although I'm not real hopeful on that. But over the years, we've engaged in this discussion a lot. And so I think you guys are going to have a very nice opportunity to get perspectives kind of reassessed. Well, first of all, up here, the American Meteorological Society came out just recently, within the last month, with this statement. And the surprising thing is that this statement is from an organization that really resisted the whole concept of climate change for a long time. And over the years, over 30 years, going back all the way to about 1980 or so, they've seen and watched enough and gathered their own data and seen things change sufficiently to make them write this as an organization. And so they now believe that the bottom sentence there is that the dominant cause of the warming since 1950s is human activities. I have 20 minutes to do something I struggled to do in 3 days, and we have to realize that there are people that have spent lifetimes studying this whole climate change issue. And it's a daunting task, but I'm going to ask for all of you to try to hang in there, and I have minimal numbers. I think Mr. Haan has a whole bunch. So hopefully it's mostly going to be critical thinking in the best sense of the word. What I want to do is talk about a little bit about the nature of science, how science works. Then I'm going to talk a little bit about the carbon dioxide impacts that humans have done, and then follow that up with a little bit of the methane impacts that we're engaged in. Methane isn't really in the news right now, but it's something that could become a challenge to us in the future. Science, what is it? Well, it's a systematic way to go about understanding how the world works. I mean, we're all curious about different things, and over time, we've developed a systematic step method that allows us to come up with a question, develop a hypothesis, write an experiment, collect data, and then we see if the data supports what we thought would happen or not. And we've done this both formally and informally. In the last 100 years or so, science has really taken to the internet, and we have scientists sharing information in real time throughout the world all the time now. If I want to do an experiment in something, I write an experiment, I do the experiment. If I want to get it published, I submit the experiment to others that know what I'm talking about, that are experts in the field. And then through that critical process of them asking me questions and then maybe finding a mistake in my procedure, in that critical process, if I can get it published, then I can have something that will share information with other people in the world. If my experiment is flawed and they find too many mistakes, not only do I not get the publishing of the paper, but I also don't get funding in the future. So in most universities around the world, scientists are very much engaged in this peer review process. We have a lot of wonderful things. I would imagine Mr. Haan has a cell phone in his pocket right now. I would imagine that Mr. Haan, in some ways, uses a computer. Oh, look, right in front of him. What's so exciting is that we now, if I have a problem with my body somehow, I can go get an MRI and I can find out what's happening inside my body without surgery. And those same scientists that have done those painstaking experiments that allow us to develop these products, that same drive has allowed us to actually figure out other things too. We have the ability to take sunshine and turn it into electricity directly. We have panels that, this is the new thing, it's called ACPV. Woohoo! Almost like ACDC, but not quite. ACPV is a panel that actually has three wires coming out the back. You plug it directly into your electric box and you have alternating current from the sun. It's a beautiful thing. And we also can get energy from the wind. And that's a wonderful development. From the same kinds of guys that have those curiosities, we have other people that are curious about what's going on with the climate. And they have done a lot of research and given us great things to consider too. This is from the Journal of Climate, which is the world-renowned expert group. They have said that the global climate's been warming. And I hate this because I'm going to kind of read this, but it's likely to continue over the coming decades. Heat in the ocean is going to raise the sea level. That after we stop our CO2 emissions, and have stabilized them, the temperature in the ocean will continue to distribute itself, and it's going to continue to rise. And therefore, despite any aggressive CO2 mitigation, regional sea level rise is going to be one of those things that we have to think about. When we talk about the world of economics, storm damage is a problem, but sea level rise is a bigger problem because about 1 in 6 people in the world live within 30 feet of the ocean. So when we talk about sea level rise, we're talking about something that could impact a lot of people. Now, when we talk about climate change, and I've talked to political science classes, has anybody heard me speak to one of your political science classes? Okay, not yet. But anyway, when the political science classes, what I say, you guys know everything you need to know about climate change. You know that if you have a black asphalt over here and you're standing on it in bare feet, it's really hot in the summer sun. And if you step on white sidewalks, they're cool. You know that if you have a white sidewalk and after a rain, if there's a little puddle of water on the white sidewalk, that if the sun is hitting that puddle, you know that the water is warmed much more than the white sidewalk, and that's because water absorbs 90% of the sunlight that hits it. So you also know that money doesn't talk, that money screams. That if you have enough money, you can throw it at a problem and pretty much kind of figure out ways to change things so that you can have your way. And one of the things I was surprised about in the election that we just had, local elections, some people were spending $28 per vote to get elected. And that means the people and politicians the campaign costs are so high that only the wealthy are going to be able to campaign, and that's kind of a challenging thing for democracy. You've seen this graph. I'm sure Mr. Haan's going to tear this apart saying, hey, you know, we've had periods of cooling. And if you look at this, right here's a period of cooling, here's a period of cooling, here's a period of cooling, here's a period of cooling. But overall, since 1880, we've seen nothing but temperature increase. And that's a problem because it's melting our ice, the Arctic. You've probably all had the experience of sitting on your back patios with a glass of ice, and as long as you had, with pop. So as long as you had ice in that glass of pop, the ice would maintain the stability of the temperature of the liquid by giving up its cool temperature to the liquid. The temperature would stay constant as long as there was ice. Even a little bit of ice, it would stay constant. But as soon as the ice disappeared, the temperature of the liquid went up rapidly. And so this is a problem because if we look at the 2012 data for the Arctic, it was the worst bit of thaw that the Arctic has ever seen. And you can, when I talk to Mr. Haan, he oftentimes throws lots of details and statistics, and it confuses one. But we have to be able to think beyond numbers and just look at the general trend. If the trend is a trend that can continue without problem, that's called sustainability. If the trend is one that's going to ultimately become a problem, that's a trend that we have to deal with. The Arctic is melting. That's a trend we have to deal with. In 1984, you can see that the Arctic was kind of large. It had shrunk quite a bit from the previous few decades. But in 2012, it was so open that you could actually sail a sailboat through it, which humans had never done. We don't need science to interpret pictures. We know that ice isn't just melting on the Arctic, ice is melting throughout the world. And one of the big complaints is that it's hard to find experts that aren't on the take. And I think one of the best scientific groups out there is Mythbusters. So let's see what they have to say about climate change.
The heat's on back at Ice Station Central. The greenhouses are ready, and the JD Ice Dolls are chilling out. But can their small-scale greenhouses back at M7 really produce a plausible greenhouse effect? The guys head off to consult an expert at UC Berkeley. And after a little demonstration showing the power of ice...
Oh my God!
It's down to business.
So I've heard a lot about people making models to predict the future of global warming. And with all the complicated systems on Earth, wouldn't that be a little difficult?
We can do experiments on small scales in the lab. We can make observations on a global scale. But you're right, it is hard to replicate in a 3-foot by 3-foot chamber. It's a challenge. I think it can be done, but it's a challenge to replicate that.
Challenge, that's Mythbusters' second name. And back at M7, it's time to commit the Jamies to a watery grave.
Poor Jamie's looking at you like that.
That ice-cold stare.
Try working with them all the time.
Everything has to be kept identical in this experiment.
That looks good right there. So that's 1,570 foot candles. So let's try to get all the lights so that that amount of light is going into each greenhouse.
Okay.
Accurate thermometers are essential
These thermometers measure a tenth of a centigrade.
to make sure it all runs to plan. The guys have called in Manish Gupta, a gas monitoring expert from Los Gatos Research. The Earth's CO2 levels stand at around 350 parts per million, and methane, a tiny 1,800 parts per billion. But amounts that small are no problem for this gear.
For methane, it's in the part per billion level, and for CO2 in the part per million level.
So now they can up the greenhouse gas levels in minutely accurate increments. And once the gases are in, everyone can chill out and watch ice melt.
Let's start melting some Jamies.
M7, it's the big freeze. The temperatures have been steady in the controlled greenhouses, while...
The methane and the CO2 have been a degree higher consistently.
But after 3.5 hours withstanding the heat, the Jamies finally crack.
So we've let the experiment run for 4 hours, and I think from the results that we're getting, we can come to a conclusion. Both the methane and the CO2 greenhouses remain hotter than the control. Throughout the whole experiment, it looks like the gases do increase the temperature inside the greenhouses.
The CO2 greenhouse stayed steady on 24.8 degrees Celsius. The methane on 24.9. And both the controls were consistently a degree cooler.
I think that this is showing that CO2 and methane are major culprits for global warming.
All right, so the results from the global warming experiment were pretty conclusive.
Yeah, the greenhouses with carbon dioxide and methane stay consistently warmer than the control.
Yeah, it was almost 1 degree Celsius warmer the entire time.
All right, so this one's confirmed?
Confirmed.
All right, so there are some scientists that haven't been bought yet, and you can see that they did an experiment. They looked at two gases, CO2 and methane. They slightly increased the gases in the chambers, and the chambers that had the CO2 in the chamber at a little higher level warmed up more than the control, which was a concentration that the Earth might have had maybe 100 years ago. The question is why? Why is this happening? Well, it turns out that CO2 is kind of like a sweater for the Earth. It allows shortwave infrared radiation to come in, which is heat. The heat hits the surface of the Earth, and then the light changes to a longer form of heat, radiation, and that longer form of radiation cannot escape the Earth. So we have the CO2 and methane trapping the Earth, trapping the heat around the Earth, so we're gaining more energy from the sun than we're losing. This is what's causing the temperatures to rise. And we've seen this for a long time, and the reason for that is that simply humans are putting about 30 billion metric tons, that's not pounds, it'd be 30 trillion pounds, 30 billion metric tons of CO2 into the atmosphere per year. Now, we're getting that CO2 from photosynthetic products stored over millions of years. The coal, oil, and natural gas are all products created from plants and animals that lived millions of years ago. We're burning those products now, and we're releasing CO2, and the carbon cycle can't take them all back into the plants. Do plants like CO2? Yes, but they can't absorb that much. So we see, if we go to and look at the Keeling curve, which is what was started back in the 60s, we in Hawaii have been measuring global CO2 levels for a long time, 50 years. And we see this continuous march, we see this continuous march of CO2 levels going up. The scientists said, well, gee, if it's going up now, what was it a while back, and how can we find that out? Well, what they discovered is that they could actually go to the Arctic, they could drill ice cores in the Arctic and also drill ice cores in this is in the Antarctic. They could also drill in the Arctic, but it's not like the Antarctic where you have much thicker ice. So they would drill a hole, they would then take these cylinders of ice and slice them Then they would take that slice and look at the inside of the ice, and there were capsules of atmospheric gases that had been there all the way back 600,000–700,000 years. So we've seen what the composition of the atmosphere is way, way back. And from that information, what we're able to do is look and see what CO2 levels have been doing in the past. Every time we've had an ice age, the CO2 levels were about 200 parts per million. Every time it was a warm period, we'd have 250 parts per million. And science allows us to predict what would those gases be at a given temperature state of the planet. If it's 250, it's going to be a warm phase. If it's 200, it's a cold phase. And from that, we extrapolate and look at what we're doing today. This 350, which the Mythbusters was actually studying, is not what it is. We're at 395 today, and it's going up rapidly. And so, given the increase in CO2 up here, since temperature is always impacted, or CO2 impacts the temperature, what we're going to do is, instead of seeing a warm period, we're going to see hot. And that's what the scientists are nervous about. This is an animation from NASA based on all kinds of data around the world, but that's a lot of science has been helping us with this. And what it shows is over time, what's happened to global temperatures. The white color is neutral, blue is cooler than normal, yellow is slightly warmer, orange is warmer yet, and red is very hot. And in the 50s and 60s, you can see that it's turning more yellow. In the 70s, you see some orange showing up. In the 90s and in the 2000s, you can see how hot it is getting up in the Arctic. So this data allows us to understand that the higher temperatures are helping to melt the ice. And now the question is, human scientific impact. What's the scientific understanding that we have that humans are causing this change? Other than just the pure amount of CO2 that we're burning every day for cars and transportation and electricity, science allows us to actually see where that carbon in the atmosphere is coming from. We know that there's a gentleman I worked with this last summer, Dr. Jacobson, down at Northwestern University. His equipment allows us to look at the isotopes that's in the atmosphere, and we can trace those isotopes right back to where they were coming from. And at 8:30 in the morning, slightly after rush hour for Chicago traffic, the parts per million for carbon dioxide is 427. And we know that that's coming from fossil fuel, not from natural carbon things. So he gave us that information. Now that increase in heat that's caused by the burning of fossil fuels is causing more heat in certain areas like Texas, which is causing droughts. When you have more evaporation of moisture in Texas, it lands in other places. This is a nuclear power plant in Nebraska a couple of years ago. They had so much additional precipitation from the changing evaporation thing that that power plant almost sank, which would have been a nuclear disaster. But fortunately, they were able to save it. I worked with another professor that looked at the tundra fires, which most people aren't paying much attention to, but this one was able to burn in the Arctic area, and it creates an area where you burn off the surface, get rid of the insulation, and it starts to melt the tundra underneath, which is full of organic matter, which as it breaks down can actually cause methane to be released. And I'll show this video, and then after this I'll turn it over to Mr. Haan.
We're out standing on a frozen lake in interior Alaska, outside of the University of Alaska Fairbanks campus. And this ice is already about 20 centimeters thick, so as it's been freezing up, methane gas has been coming out of the bottom of the lake and getting trapped in the lake ice. If you look at the shore, you can see that there are lots of trees that are falling in the lake and they're dying. What's happening is the permafrost is thawing. The ice that was in the ground, when it melts, causes the ground surface to collapse. When the forest falls in and any organic matter, dead plant and animal remains that were in the permafrost, thaw out in the bottom of the lake, microbes decompose it and it generates methane. And methane doesn't like to stay in the water in solution. it forms bubbles, and those bubbles make their way to the surface. In the summertime, the bubbles pop and they enter the atmosphere. In the winter, however, this ice forms a cover on the surface of the lake, and the bubbles get trapped right under the ice, and the ice thickens and freezes around them. So what we have out here is like a time-lapse photograph of methane emissions from the lakes. Methane is a very potent greenhouse gas. A molecule of methane is 25 times stronger than carbon dioxide. Methane is formed in millions of lakes around the Arctic where permafrost is thawing. And each year, these lakes are emitting already tremendous amounts of methane. But when we look at how much carbon is in permafrost still frozen, and the potential for that permafrost to thaw in the future, we estimate that more than 10 times the amount of methane that's right now in the atmosphere will come out of these lakes.
All right. So Mr. Haan's turn. And basically, I think he's going to do a climate science investigation for us here.
All right, timers, are you ready? Mr. Haan, you may begin your 20-minute opening statement now.
Well, I think I've already succeeded in one of my goals of coming up here, and that is to show everybody here something that you may not see. Now, Mr. Wilms and I have known each other since I've been at Stevenson, about 22 years, and we've been very good friends. And I want to point out that it is possible for us, even as friends, to vigorously disagree. You don't have to agree with somebody all the time to be their friends, and if you disagree with somebody, it's also, you can stay friends. We have discussed this, argued about this, fought about this, for a long time, and so it's a pleasure to come up here. I'd like to thank the Truth Seekers for letting me have this forum to come up here and discuss things with my friend, Mr. Wilms. Okay, let's go. If the Earth has a fever, where do we stick the thermometer? Okay, this is an interesting question. How do we know that the Earth has a fever? Actually, let's see. I gotta turn this on. I'm good at technology. Here's the questions, okay? Is it getting warmer? Really? Why? And I think there are 3 questions that need to be answered, 2 of which I'll try to do now, and then 1 maybe a little later. 1, what are the reasons that the Earth can be warming or cooling? Is there scientific uncertainty in this? Can we trust those who are telling us that global warming is happening? Has there been a corruption of science? And then finally, can we come to a conclusion? What should we do about this? And it is possible to note that what we should do about this is nothing. Okay. Well, wait a minute. The Earth is always getting warmer. It's or colder. If you look at this graph from I think it's from the NOAA, it shows lots of lines. It shows lots of proxies. All the color lines are what they call proxies to measure the temperature. But the interesting line is the black one. The black one is the average. And look what's happening to the average. We had a time when there was great climate change. Huge global warming called the end of the Ice Age. And then it came into something called the Holocene warm period, where the temperature was actually at its highest. And since that time, temperature has been going up and down, up to the current time, where it's going up again. But wait a minute. How can this be? How can this be when we're told that that, right there, is what's driving climate? The Earth was much, much warmer during what they call the medieval warm period. Now, we have pretty good history of the medieval warm period. The purple line here. The world was much, much warmer then, and London didn't sink. Chaucer didn't mention it. In fact, global warming seems to have stalled out. Okay? This is from 2 weeks ago, from the Met. And the numbers they got are from the Climate Research Union at East Anglica. They say that, look, climate warming, or global warming, has ended. But how can that be when we're told this is driving our climate? Well, in fact, if you look at the temperature and the CO2 reconstruction for the last thousands of years, there doesn't seem to be much of a connection. The blue line is a proxy from Greenland. At the bottom, the red line is atmospheric CO2 from the EPICA dome core. There doesn't seem to be much of a connection. But don't take my word for it. Let's see if I can get this out.
And ice cores are frequently cited in support of the theory of man-made global warming. But there is something in the ice core data that is very rarely mentioned. Professor Ian Clark is a leading Arctic paleoclimatologist who looks back into the Earth's temperature record hundreds of thousands of years.
When we look at climate on long scales, we're looking for geological material that actually records climate. If we're to take an ice sample, for example, we use isotopes to reconstruct temperature, but the atmosphere that's imprisoned in that ice, we liberate, and then we look at the CO2 content.
Professor Clark and others have indeed discovered a link between carbon dioxide and temperature. But the link is the wrong way round.
So here we're looking at the ice core record from Vostok. And in the red, we see temperature going up from early time to later time at a very key interval when we came out of a glaciation. And we see the temperature going up, and then we see the CO2 coming up. CO2 lags behind that increase. It's got an 800-year lag. So temperature is leading CO2 by 800 years.
There have now been several major ice core surveys. Every one of them shows the same thing. The temperature rises or falls, and then after a few hundred years, carbon dioxide follows.
Wow! So what's causing the temperature to go up and down? Well, there are several different things. Believe it or not, climate science can have an answer. Maybe, just some intriguing questions for those of us who are willing to listen. How about the sun? The sun provides the basic temperature for the Earth, but the sun is not a stable body. The sun is constantly giving off different amounts of energy to control the Earth's climate. Right? That's why they have sunspots. And humans have measured this activity through the counting of the sunspots with the idea that counting the sunspots, and this comes back from the 1600s and before, that if you could count the sunspots, somehow that was connected to the weather. In fact, NOAA Space Center Rodney Vernick has shown a considerable correlation between sunspots and global mean temperature. In this one, sunspots are represented by these faint lines. And you can see that we have ups and downs in the sunspots. But the temperature seems to follow along. Why could that be? Scientists have even shown a connection between solar wind and cloud formation using what's called the CERN Super Collider in Switzerland. This is new, guys. This is brand new. This is August of 2011. The clouds, Cosmic's Leaving Outdoor Droplet experiment, examines the role that the sun has and sunspots have in energetic particles from deep space play in the cloud formation. The answers? Well, if you take the temperature and you put it with the sunspots, you get a much better correlation than you would with CO2. Professor Judith Curry of Georgia Institute of Technology says, the responsible thing to do would be to accept the fact that the CO2 models may have severe shortcomings when it comes to the influence of the sun. As for the warming laws, she says many scientists are not surprised. Okay, there's a sun, but could there be something else? Well, yeah, the waves, the water. Now, this is something I didn't even know until just recently. The temperature of our main bodies of water, Atlantic, Pacific, go through this kind of periodical, decadal, in terms of decades, ups and downs. This is for the Atlantic multi-decadal oscillation. I'm trying to say that 10 times. Okay? Up, down. Up, down. Up. Pat Brekke, senior advisor at Norwegian Space Center, said some scientists found the importance of water cycles difficult to accept because doing so admits that the oceans, not CO2, has caused much of the global warming from between 1970 and 1997. Here in the U.S., and the U.S. is important, and I'll get to that a little bit more, but we have the most accurate sensors. When people want to see an accurate thing of the Earth, temperature of the Earth, they go to the U.S. Ours is a Pacific oscillation. Why? Because weather travels west to east. And look, it looks like the Pacific oscillation goes up and down and up and down without any help from us humans. Why does this matter? Well, when you have ups and downs, when you have downs, that leads to La Niñas, which tends to make the temperature of the United States cooler. When the temperature, or when the oscillation is high, you have La Niñas. El Niños. We had a super El Nino in 1998, which is really weird because that's the temperature that everybody looks at and says, oh, it got so hot. Well, yes. In fact, now I tried to line up this perfectly, and I couldn't, but you can kind of see that as this goes down, the temperature goes down. As this goes up, the temperature goes down. This goes down, the temperature goes down. As this comes up, the temperature comes up. So there's another reason why temperature could be driven by something else than CO2. Okay, all I'm trying to do here, let me just stop for a minute and just mention something. All I'm really trying to do is raise some uncertainty. That's what science is about. Science is about raising uncertainty so that you can look and find your own answer. This next part, sorry David, this is where things get a little nasty. Science is behaving badly. One problem. Scientists are people too. And global warming is no longer a scientific issue. It is an issue with broad and even global policy agenda. And that creates a problem. I don't know if you've ever heard of it. It was called ClimateGate. 2009. Over 2,000 emails were stolen from the University of East Anglica's Climate Research Unit. If you don't mind, I'm going to call it CRU from now on because that's a heck of a lot easier than East Anglica's Climate Research Unit. The East Anglica CRU is one of the 4 main compilers of global warming data. Okay? If you're saying, where does this global warming thing come from? There's 4 of them. 1, CRU. 2, a Japanese. 3 for the Pacific. 3, NOAA. And 4, GISS. What these emails were people at the CRU discussing things with the other compilers. Now, they were discussing things like dinner, I'm coming into town, let's get together. But they were discussing something else. The big story, the story that everybody focused on, was the accusation in the emails. They talk about manipulating data. Now, I don't think that was a big deal, mainly because everybody kind of knows they manipulate data. And here's the part that I find shocking. The real story should have been that the emails revealed global warming scientists, these are the heads of these global warming compilers, were discussing threatening editors who publish anti-global literature. They were discussing ways of keeping anti-global warming literature from keeping into panel reports. Even, they said, this is a direct quote, even if we have to redefine what peer-reviewed means. You don't agree with us, you don't get published. Discussing ways to evade freedom of information requests made for raw data. I'm going to put some stars. I want to come back to that, because that's an interesting one. Remember I mentioned about the CERN and the clouds? The authors of what's called the Danish heresy, notice the religious part of this, were unable to get funding or permission. They were blocked from funding or permission to do their experiment at CERN, at the CERN Super Collider for 8 years, despite the acknowledgement that the theory could have a critical impact on global climate understanding. In fact, the head of CERN, in an unprecedented move, prohibited the scientists from drawing conclusions of the major experiment. Scientists should refrain from drawing conclusions from the latest experiment. I have asked the colleagues to present the results clearly, but not to interpret them, because, he says, that would go immediately into the highly political area of the climate change debate. Hello? This is science. Here's something interesting. I want to come back to this evading freedom of information requests. On these ClimateGate emails, they were talking about, okay, I just got hit with a freedom of information request. What is freedom of information? Well, guys, if we pay scientists to science, we have the right to their data. Right? We have the right to have their data. We paid for it. The government has funded it. We should have the data. They didn't want to release the data. And they still have not released the data. Fortunately, NOAA has, in 2009, in response to a Freedom of Information lawsuit, I'll come back to that because there's an interesting little side discussion. But the CRU head, Phil Jones, said, why should I release my data? All you want to do is criticize it. Wait a minute. That's science. Here's an experiment for all you kids to do. Next science experiment. Go up to Mr. Carmichael, take the data, put it in your folder, give him the answer sheet, and tell him, well, Mr. Carmichael, I'm not going to give you the data sheet because you're just going to criticize it. But my answers are the same as everyone else's. Would he accept that? No, because it's not good science. Here's another one. Here's another problem. The hockey stick. The hockey stick is a famous kind of snafu. The hockey stick was used as a centerpiece of the United Nations Third Assessment Report. The United Nations had been putting together assessment reports since 1990. Okay? We're on the 5th one coming up in 2 years. And this is what policymakers see in order to deal with the problem of global warming. Every policymaker in the world had that on his breakfast table. Okay? And what does it show? Temperature going along, and no! We have a serious problem. But then something weird happened. A statistician from Canada, of all places, reconstructed the computer code that was used for this. And he found, with the code and the algorithms, that you could put any numbers in there, and they would result in the hockey stick. UN later dropped the hockey stick. It's disappeared under the ice. Okay, I guess this is all hypothetical. You know, scientists would change raw adjustments. This is the adjusted temperature record for New Zealand, 1860 to 2000. It shows the same thing that we've been talking about the whole time. Cold, 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 warm, 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 warm. This is the adjusted temperature record from New Zealand, which unequivocally shows global warming. But New Zealand has their data come out. That's the unadjusted record. That's after adjustments. That's the adjusted. Last but not least, and I don't know if I'll have time to finish, I'll come back to it. There are these guys called climate auditors. They're not skeptics, although most of them are. Basically what they do is this. They say, are you basing it on the right facts? And they say, look, we have five conditions for the sighting of temperature gauge for the United States, which means the best temperatures. And you can see, okay, if you're class 1, you don't have any heat sources near you. No buildings, no parking lots. Now you're out in the open. Class 5, you have some problems. Well, what did they find? And I'll go real quick. Look, this is the temperature station for Marysville, California Fire Department. It's right there in the middle there. It's right here. Surrounded by air conditioning exhaust fans and an asphalt parking lot. Oops. What's that going to show? How about this? Glen Ferries, Idaho. Next to a power transformer. Right next to it, what do you think that's going to show? This one's fascinating. This one's recently moved to Texas. Wow. Right near, on that asphalt, near a building, near a radio tower. And look what happened when they moved it. Wow! The temperature went up. They took all of these compilers. Remember, NOAA had released their raw data, and they said basically this. If you take just the compliant thermometers, the ones NOAA says they should be using, you're at 0.155 plus 0.155 Celsius per decade, normal warming coming out of glaciation. If you take the non-compliant ones, 2.248, the NOAA final adjusted data, though, after the NOAA gets to it, 0.309. What did they do? How did they adjust it? Okay. My time is up. I will come back to this.